NFL Plus.
Wait, I asked you that thing next on there.
That's what it's on.
Correct. Nick, what's up?
I think we do one of them with like 10. We do our 6.
6, certainly.
What time's the machine is done?
I think I heard kickoff is 7:30.
4.5.
All right, so the directions here say find the exact values using sum and difference identities. So my first order of business is to look at 195 degrees and try to find two angles that are either going to add to give 195 or subtract, I should say, two unit circle angles. They'll either add to give me 195 or subtract to give me 195. 45 and 150, right? Yeah, that would be my natural suspicion as to what most of us would pick. So then if I look at my identity sheet, that looks like I should be using SD5. Everybody agree there? Because it's a tan with addition. So I plug in my identity. And again, it doesn't matter if you wrote 150 plus 45 or 45 plus 150, right? The order will not matter. You'll get the same answer either way. So now what do? I go to my unit circle and look up the values for tan 45 and tan 150. So remember, tangent on the unit circle is y over x. So at 45 degrees, y is root 2 over 2, and x is root 2 over 2. And then at 150 degrees, y is 1/2, and x is negative root 3 over 2. So far, so good. I'm going to go ahead and reduce now my fractions. So root 2 over 2 just becomes 1. And 1/2 over root 3 over 2 just becomes 1 over root 3. And I have some negative signs bouncing around there that I consolidated. Questions so far? Okay. Now, two issues with this answer. One, I have fractions inside of fractions. Don't love that. Number two, I have radicals in the denominator. Don't love that. Let's take care of the fractions inside of fractions part first. So to do that, I'm just going to multiply the top and bottom of this fraction by the denominator in the little fraction. So that distributes all the way through. Hi. Thank you. Oh, you know what? He's absent.
Thank you.
You're welcome. So far, so good? Okay. Now the issue is the radical in the denominator. This is kind of the worst case scenario for this because we have this addition and subtraction going on inside the denominator also. Hopefully you remember that to do that we need to multiply by the conjugate. So that's the same thing as the denominator, just with the opposite sign in the middle. Now to multiply this stuff, we're going to have to do some foiling. The denominator, though, I noticed that, hey, that's that difference of two squares multiplication pattern that we would have learned in Algebra 2. So I can use that to kind of shortcut through. I have like an a plus b times an a minus b. So, well, that I can just shortcut to a squared minus b squared. Now, you could FOIL it out also if you didn't remember this multiplication pattern. But I remember it. It's a shortcut. I'm going to use it because why take the long way when you have a shortcut? And then let's FOIL out the numerator. So far, so good. I remember that squares cancel out square roots. So in the numerator, I have a 3 plus 1. That gives me a 4. And the denominator, I have a 3 minus 1. That'll give me a 2. And then I have negative root 3 minus another, minus a root 3. Or really what I think about is negative root 3 plus negative root 3. That gives me negative 2 root 3s. Everybody agree with that? If I have one negative root 3 and another negative root 3, well, I have two negative root 3s, or just negative 2 root 3. And here I'm going to notice that, hey, the coefficients for each term in the numerator are divisible by 2. So it means I can reduce this. To do that, I can just think about writing this single fraction as two fractions with the same common denominator. And I can reduce the 4 over 2 to just be 2, and the 2 root 3 over 2 to just be root 3. And that guy should be my final answer. A reminder here that these are all checkable. So to do that, I'm just going to take my calculator and make sure I'm in degree mode since the original problem was tan of 195. Let's see what that decimal is supposed to be. That. And then I'll take my answer, 2 minus root 3. And what do I notice? They're the same. What does that tell me? I did it! Yay! Nick, does that feel...
Yeah, you said like the order, like which they subtract or add, like doesn't matter, right?
Oh, well, the order you subtract them would, because like 150 minus 45 is not the same thing as 45 minus 150. Okay. But the way you add them doesn't matter. Okay. Miriam.
Can we do number 3?
3?
And it's another tangent.
Yeah, it sure is. You guys like those tangent ones, huh? Sure. So the other thing that I noticed right away is that this thing is in radians. Now, you don't have to do that, but boy, it probably makes it much easier for most of us to just convert that into degrees. Pi's cancel. 12 goes into 180 15 times. So I have 75 left. So I'm going to really be thinking about this as tan 75. Again, I'm going to try to write this as a sum or difference of 2 unit circle angles. I mean, it seems pretty obvious that the sum would be what I want to use in 30 and 45. Most of us would probably see that right away without thinking too hard about it. I'll go to my unit circle or my equation sheet here and pull out the sum difference identity SD5 again, because again, it's a tangent with a sum inside. So that's going to be tan 30 plus tan 45 over 1 minus tan 30 times tan 45.
Quick question. Does it matter which degree, 30 or 45, does it matter which one we make x and y?
No.
Okay.
It will not matter with an addition problem. I want to point out to you that tan of 30 is just the positive version of tan of 150, which we just did. Tan of 45 is the same thing that we just did. So I'm just going to kind of express route to here. Is that okay? Since I'm using the same, they're essentially the same part of the unit circle. So just like I did before, multiply the top and bottom by root 3s. So I have 1 plus root 3 over root 3 minus 1. Again, we'll multiply by a conjugate, just like I did before. This conjugate would be root 3 plus 1. Again, the same thing as the denominator, just with the opposite sign in the middle. I FOIL the numerator out. And use my difference of two squares factoring pattern on the denominator. Reduce there. So in the top, I'm going to have a 4. The bottom, I'm going to have a 2. And then root 3 plus root 3 is 2 root 3s. I can do the same reducing trick that I did on the previous one. I ended up with 2 plus root 3.
Okay, I got that, but I didn't know what you did. I like this.
Okay, maybe you got lucky. I don't know. And again, totally checkable, right? This was tangent of 75. So if I type that in, and then I look at 2 plus root 3, same thing. So I know I got it right.
We also have one more.
Yeah, why not?
I don't know, like 9 and 10 were like the same. So like, I guess we can do 9.
Okay. So whenever I see the pi over 5, I'm just going to write x. And whenever I see the 2 pi over 7, I'm going to write y. Just so that it's easier for me to pick out the identity. So if I go and I look at my identity sheet, I'm going to be looking at the right-hand side of the identities. If I look at my sum and difference identity number SD5, that's what this appears to be. And again, in this problem, x was pi over 5, and y was 2 pi over 7. If I make a common denominator, that common denominator would be 5 times 7, 35. So 7 pi over 35 plus 10 pi over 35. If I add those together, I have 17 pi over 35.
I got to the addition, like pi over 5 plus 2 pi over 7. I just completely blank.
Oh dear. 6th grade was hard, It was a hard year for a lot of us.
Ago.
I'm just teasing. We can all laugh at ourselves once in a while. I do dumb stuff all the time.
I think there was like that too.
Well, there you go. That was your problem. Okay. Let's finish up chapter 6 here today. I think last time, let me check where we left off at. We had done angle sums and power reducing. What I want to do next is do some half angle problems. So let's say we're asked to find sine of, yes sir, sure. Sine of 22.5 using a half angle identity. First thing I want to do is I want to take that 22.5 and rewrite it as half of some angle. So hopefully most of us wouldn't have too hard of a time realizing that 22.5 is 45 divided by 2. Could just multiply whatever the angle is by 2 and then put it over 2, and there's your half angle thing. So the x that I'm going to be plugging into my half angle formula is going to be the 45, right? So I'm going to look at my half angle identities and see which one I want. So that is h1. So plus or minus square root 1 minus cosine of 45 over 2. Well, couple of unusual things about this identity versus the previous ones. One has this plus or minus in it. And then 2, we have this square root over the whole thing, right? So that's going to affect a little bit of what we do. Let's take care of the plus or minus part first. This doesn't mean that I should have a plus or minus answer. It just means that depending on what I start with, the answer could be positive or it could be negative. So what we would do is we'd start with the 22.5 degrees. What quadrant is 22.5 degrees in? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 1, right? And we know that because quadrant 1 covers 0 degrees to 90 degrees. So if I go back and I think about all silly turtles crawl, in quadrant 1, A stands for all sine, cosine, and tangent are positive. So I don't want the plus or minus, I just want the plus. Because this is a value of sine in the first quadrant, must be positive. Is everybody okay with that? Sure, Mr. Gulick, I guess so. You know, if it was sine of 105, you know, still would be positive, right? Etc. You know, depending on the quadrant. Okay, so there's that part. Now let's go ahead and evaluate cosine of 45 degrees. I go to my unit circle and look at 45 degrees. What's cosine of 45 degrees? Yeah, root 2 over 2. Again, should have your identity sheet out while we're working on this, right? That'll be a massive help. If you've lost yours or you didn't get one in the first place, there's more on top of the file cabinet there on the top, that black file cabinet right over there if you need an extra one. Or you didn't get one in the first place. It's like, Mr. School, I need a first one. Okay. I got extras. All right. So it looks like we got that fraction inside a fraction thing going on again, right? Right here. So what do I need to multiply this big fraction by to get rid of the little fraction? Just the denominator of the little fraction, right? So I do that. Almost. Why isn't that quite right? Because of the square root over top of the whole thing. Yes, exactly right. Remember, if we go back to like algebra 2, if I do something inside of a square root times something not inside of the square root, I can't multiply that stuff together, right? But if I have something under a square root times something under a square root, then we can multiply them together. Everybody's okay with that? So what we want is that. You guys okay with why I needed to do that? And then this just distributes in just like it did before now. So far, so good. Still something Mr. Kulik doesn't love about this, though. What's that? Not the square root in the square root. I don't mind that. That's okay. Well, square root of 2 isn't really divisible by 2. It's not the negative. It's that I have a square root in the denominator. So again, remember from Algebra 2, you should know that the square root of a fraction is the same thing as the square root of the numerator over the square root of the denominator. So really, even though there isn't a square root symbol expressly written in the denominator, there's still one there. We don't love that. But here's the good news. If I use that rule that I just wrote there on the side, I can write it like that, and what do you notice? But what is the square root of the denominator? It's just 2, right? The square root of 4 is just 2. I don't have any like nasty algebra to do to get rid of that. I can just like evaluate it. That happens a lot of the time. And that's as good as we can do. Now, I want to caution you right now that I'm going to be picky about your neatness on this. If your square root is over the entire fraction, you need to make sure that when you draw your square root, I can tell it's covering both the numerator and the denominator. When your square root is only in the numerator, really be careful to draw your square root so that it's only in the numerator. Notice here when I've drawn my square root, the check mark of my square root is well below the division bar in the fraction. And when it's only over the numerator, I can tell that the fraction bar is underneath the check mark in the square root. You guys see what I'm talking about? I am going to be picky about that when I look at your papers come test time. Just to be honest with you, give you fair warning. Okay? So just be careful about that when you're doing your homework, when you're writing things down, that I am going to be picky about the neatness of like, can I tell whether your square root symbol is covering the whole fraction or not? And should it be covering the whole fraction or not? Right? So just be a little bit careful about that. Okay, let's do one more. Okay. First things first. I'm going to try to rewrite this as a half angle. So negative 105 is half of what? Who can do it in their head? Negative 210, thanks, said you. Now, is negative 210 a unit circle angle?
Yes.
Yeah, how could you tell?
Yes, the unit circle says.
But this is negative 210, not positive 210.
Shoot. 150.
Yeah, so if I add 360 to that, it's really the same thing as 150 over 2. And that 150 is definitely a unit circle angle, so we're good, right? Does everybody see what we did there? Okay. So we'll go look at our identities. Which identity do I want to use? For cotangent of 150 over 2. Yeah. What am I going to do with that? Is there a cotangent identity? But there is tangent, right? So remember that R6 tells us that cotangent and tangent are reciprocals. So I can think about that. And then I can use H3. Let me draw a little thicker that bar. The question becomes, if you look at H3, this is unusual. How many versions of H3 do we have? 3 versions. Woo! What does that mean, Mr. Kulik? You could use them all interchangeably. They will all work, but do they all look the same amount of difficulty? No. Now, me, being Mr. Kulik, I'm an efficient guy. I don't want to do more work than necessary. So I want to make sure I'm being careful here and picking the version that's going to allow me the least amount of work. One of them I should be able to throw away right away by looking at it. Which one of these 3 do you think Mr. Kulik wants no part of? First, second, or third version of this? The first version. I don't want any part of the plus or minus, the radicals. I have trigs on top and bottom. Yuckarooski, get out of here. So it's going to be a choice between 2 or 3 for me. Is everybody cool on that? When I look at version 2 and version 3 of H3, the thing that I want to avoid is if I have to rationalize the denominator, I don't want like 1 plus square root in the denominator because I don't want to have to do that FOIL crap. You guys buy that? So I want there to just be the single trig function in the denominator. I don't want the 1 plus or the 1 minus in the denominator. So the version I want is well, you'd think H2, but remember we have to take the reciprocal of it. So really I want, or the second version of H3, I really want this third version of H3 because I have to flip it still. I know, that was tough, Mr. Kulik. So when I flip this now, because it's 1 over that fraction, I get this. Where everything is where I want it to be. Yay! Math. So now we just go to our unit circle. Cosine of 150 is, who can tell me? Great. And while you're at it, sine of 150? What's the issue? Fractions inside of fractions, right? What do I have to multiply by the top and bottom by to take care of that? Yeah. So multiply by 2. Bloop. So I end up with 2 minus root 3 over 1. And anything over 1 is just itself. There's my final answer. Notice that this one I didn't have to decide whether it was going to be positive or negative, because in H3, the other 2 versions, version 2 and version 3, don't have the plus or minus there. So the problem takes care of it by itself. Yes. Isn't that nice? Yeah, of course it is. just as an aside to check, negative 105 would be over here in quadrant 3. And tangent should be positive in quadrant 3. The square root of 3 is less than the square root of 4. So it's definitely less than 2. So 2 minus something less than 2 is positive. You would also type in your calculator to see. Edu. Absolutely. What do you guys think?
Get from the H3 part to the 1 plus cosine.
Well, I had 1 over that fraction, so I just made the reciprocal. That's what 1 over the fraction means. Does that feel okay? Just like when we were like writing sinusoids, if I had 1 over 1/2, that was just 2. Because I just made the reciprocal to 1/2. Okay, that's going to finish us up for chapter 6. There's more in chapter 6, but it's not stuff that I'm going to ask you guys to do in this class. So you guys should be able to do 23 through 26 and then worksheet 1. We're going to do the chapter 6 test with the chapter 7 stuff together because there wasn't a lot here to do. So that's the plan. Test will be like 2/3 chapter 7, like 1/3 chapter 6, something like that. Maybe 3/4, 1/4 or something in that could somewhere in there. I haven't finished it. Like I have a chapter 6 test, and I have a chapter 7 test, I haven't put them together. I'll get it. I'll tell you more when it's closer. When it's time to care a little bit more. You know what I mean? Right now, it's not time to care about that. What do you guys think? Okay. Yeah, so do some practice. If you get stuck on something or you have questions or you're not sure if you want to check or any of that jazz, come up and talk to me. I'd be happy to help you out. Otherwise, I'm going to get out of your hair and let you do some practice. Cool? Okie dokies.